Okay, let's look at a few more examples involving L'Hopital's rule. Here's the limit as x approaches 2 of x squared minus 4 over x minus 2. And you can see that if we put in 2, I'm not going to write it, but just think it through. 2 squared minus 4 is 0, and 2 minus 2 is 0. So that gives us 0 over 0. So let's apply L'Hopital's rule and take the derivative of the numerator, which will be 2x, and the derivative of the denominator, which is just 1. The derivative of x is 1, and the derivative of a constant is 0. So now we can substitute x equals 2 right here. And 2 times 2 is 4. So the limit is 4. So really simple example, but it's just worth noting that this is an example that could be solved without L'Hopital's rule. And you remember how we do this. If we can't substitute this x value in and get an answer, we can try to simplify this expression. And so this would be the limit as x approaches 2. And this simplifies because x squared minus 4 is the difference of two squares, so we can factor the numerator as x plus 2 times x minus 2, and then the denominator is x minus 2. And so x minus 2 cancels out, and we're just left with the limit as x approaches 2 of x plus 2. And then this can be evaluated by a substitution. Put in a value of 2 right there, and you get 2 plus 2, which is 4. So just taking note of the fact that L'Hopital's rule gives us the same result as the techniques of evaluating limits that we learned earlier. Here's another example. The limit as x approaches pi over 2 of cosine of 2x plus 1 over sine x minus 1. And so let's try putting in pi over 2 here. Then when we do that, we get cosine of 2 times pi over 2 is cosine of pi plus 1 over the sine of pi over 2. Remember, on the unit circle, pi over 2 is right at the top. Sine of pi over 2 is 1. So then cosine of pi is negative 1. So negative 1 plus 1 is 0. We get 0 over 0. So let's try applying L'Hopital's rule. This will be the limit as x approaches pi over 2 of the derivative of the numerator. And the derivative of cosine is negative sine. And we also have to apply the chain rule because we have an inner function here. And so this is going to be negative 2 sine 2x. And then the derivative of the denominator, derivative of sine x, is cosine x. And if we try to evaluate this by substituting pi over 2 for x, we get negative 2 sine of pi. 2 times pi over 2 is pi. And sine of pi is 0. So we have negative 2 times 0 over cosine of pi over 2, which is also 0. So that gives us 0 over 0. But we can apply L'Hopital's rule again. So this will be the limit as x approaches pi over 2. And the derivative of negative 2 sine 2x is going to be negative 4 cosine 2x. And then the derivative of cosine of x is negative sine x. And this we can evaluate at pi over 2, and it should work. So 2 times pi over 2 is pi. So this is cosine of pi, which is negative 1. So we have negative 4 times negative 1 over negative sine of pi over 2, which is negative 1. So this is negative 4. So again, sometimes we have to apply L'Hopital's rule more than once. And here's one more example. Limit as x approaches 0 of 3x squared minus 1 over x minus 1. Okay, one thing you don't want to do, and this is what is demonstrated in this problem, you don't want to just jump straight to L'Hopital's rule. You want to try substituting first, and that's what we've been doing. And here's why you always want to do that first. As x approaches 0, let's put in a 0 value here, and we get 3 times 0 minus 1 over 0 minus 1. So that's, well, negative 1 over negative 1 is 1. Okay, so we get an answer. So that's it. We don't apply L'Hopital's rule. If we did, if we said the limit as x approaches 0 of the derivative of the numerator, so that's going to be 6x over the derivative of the denominator, that's 1. Well, this we can evaluate at x equals 0. That's just 6 times 0 over 1, which is 0. Look at that. A different answer than we get, and than we get from the ordinary substitution. And this one is correct. This is wrong. Applying L'Hopital's rule when you don't need to is typically a mistake. L'Hopital's rule, remember, applies to indeterminate forms, and this is not an indeterminate form at x equals 0. We can substitute the value 0 into that expression, so do that to get your answer. Don't apply L'Hopital's rule when you don't need to.